Guys, welcome back. Today we'll be discussing how pulse oximetry works. So if you're a nurse, I'm sure you use a pulse oximeter every day, so you may be curious as how this device actually works. So hopefully this video will give you a quick and basic understanding of that. So we'll get right into it here. So the first concept we need to know, and really the major concept of this whole thing, is that pulse oximetry works by measuring light absorption. So pulse oximetry works by measuring light absorption. Okay, and how it does this is, so there is a probe. So this is my pulse oximeter here. I'm not the best at drawing, but hopefully you get the idea. So there's a probe on one side of the pulse ox, and there's a sensor on the other. So probe on one side, sensor on the other, and this probe is going to send two different wavelengths of light through the finger, the ear, wherever you have it connected to the sensor. So that's a major concept here. So there's two different wavelengths of light that are measured. So the first one we'll discuss is infrared light, and the second is red light. Okay, so like I said, this probe will send infrared and red light, so it'll send both of these through. And how this works is, so we know that hemoglobin carries oxygen in the blood, okay? Oxygen in the blood. And what happens is hemoglobin that has oxygen connected to it, so oxygenated hemoglobin is going to absorb a different wavelength than deoxygenated hemoglobin. So oxygenated hemoglobin absorbs infrared light, while deoxygenated hemoglobin absorbs red light. Okay, so infrared light, this is oxygenated hemoglobin. Red light, this is deoxygenated hemoglobin. Okay, so when we know this, then we can go through an example here. So if oxygenated hemoglobin absorbs infrared light, and this sensor and the SpO2, or your pulse ox, I should say, is measuring light absorption. So then we know that the more infrared light that is absorbed, means there's a higher concentration of oxygenated hemoglobin, right? And what does a higher concentration of oxygenated hemoglobin lead to? That's going to lead to a higher SpO2. And then we can do an example just the other way, right? So the more red light that is absorbed, this means there's a higher concentration of deoxygenated hemoglobin, and a higher concentration of deoxygenated hemoglobin correlates with a lower SpO2. Okay, so that is pretty much a basic overview of how the pulse oximeter works and how you get your SpO2 values. Major concepts here to know are going to be definitely the two different wavelengths of light that are measured. And just remembering that oxygenated hemoglobin is going to absorb the infrared light, and deoxygenated hemoglobin is going to absorb the red light. And by knowing that, then you could probably work through this here and kind of understand the concept a little better. So hopefully you liked the video.